I'm not.
Whose book is this?
Okay. So, here's an interesting question. So you have a candle that is 2 centimeters tall. Okay, about like that. You're on an optical bench, and here's the screen that's 2 meters away. Okay, or 200 centimeters, however you want to think about it. Yes?
Wait, is this the lab?
Huh?
Is this the lab? Or is
It's
this
the
notes
precursor to the lab.
lab? Notes?
Okay? So, 200 centimeters away, 2 meters, however you want to think about it. And there's a lens. And you want to form an image over here on the wall. Okay? The focal length of the lens is 32 centimeters. So right away, what type of lens does it have to be? Concave or convex? Convex. Why do you know it's a convex lens? Because if it was a concave lens, could you even make an image on the other side? No. No, because it's spread out. So right away, you know this is a convex lens. So right away, what do you know about the sign of the focal length? Positive value. Okay? So, here's the candle, here's the lens. Is this distance to the left so or side? And then you got side, right? Now, here's the tricky part of this. If I add so plus psi, what do you get? No. So plus psi add up to equal what?
F.
No.
1 over F.
I already did that, Mike.
200 centimeters.
200 centimeters. Okay.
Shaq said that first.
Oh, actually, no. Listen.
I did not hear I did not hear that.
Oh,
I wish I were so plus psi add up to 200 centimeters. True?
Yeah.
But I can't solve that because I have 2 variables with 1 equation. Now, what else do you know? 1 over psi plus equals my focal length. Now, you're told the focal length is 32 centimeters. But is that focal length going to be a positive or negative number?
Positive.
Why?
Because it's a convex lens.
So it's going to bring the light together. So this is going to equal 1 over 32. Right? Cool with what I've done so far?
Yeah.
So let's solve that top equation for psi. It really doesn't make any difference which one you pick. We'll solve it for psi. So psi is going to equal 200 minus so. So could I put that in for psi?
You could.
Yeah.
1 over 200 minus so plus 1 over so equals 1 over 32. Cool with what I did so far?
Yes.
But this is still a train wreck and trying instead of ways of solving it. Now, what's the least common multiple of 200 minus so and 32?
32 times 200.
Beautiful. So the least common multiple of all of this random things is, sounds like a football play, 32 so on 5 multiplied by 200 minus so, right? That's the least common multiple of this whole thing. So I'm going to multiply this by 32 so times 200 minus so. Right? Because that's the least common multiple of everything. True? Okay. What? Well,
I mean, I know where.
what if I asked you to add 1/2 and 1/3?
common denominator. You can't do it.
We did like cross multiply.
Yeah.
Well, in this case, what's the least common multiple of 2 and 3? 6,
Oh,
right?
yeah.
Sometimes you better, but it's not.
Okay. So I took 2 times 3 and I got 6, right? So I'm going to do the same thing here. Okay?
So you just multiply all?
Multiply all together.
Oh, okay.
Okay? Now, so when I multiply all of this together, just shut up.
Yeah, that's.
You're gonna shut up.
God, Gavin, quit talking.
I know.
He was having a Gavin moment. Okay.
Yeah.
So do you agree that the 200 minus SO is going to cancel out?
Yeah.
Okay. So what I'm going to get then up there, that's going to cancel out. So I'm going to have 32 times 200 minus so, right? Okay? Go with that. That's what I'm going to get. I'm going to multiply everything by the same thing. So then what's going to cancel out of the next one? Just the so what are you going to have? So this is just over so. So I'm going to have 32 times, well, in this case, 200, I screwed that up. My bad. I wrote it in the wrong place. This, the 200 so, this is just going to be 32 so. This is going to be 32 times, I wrote it in the wrong place. 200 minus so,
It's like February.
and this is going to be
So 200 minus.
so and 200 minus so. Okay? Now, conveniently, I'm going to distribute this. So I'm going to have 32 so. I'm going to take the 32 and distribute that. So to save us some time, you get 6,400 minus 32 so equals 200 so minus so squared. Now, this is conveniently what's going to happen. I've got 32 so minus 32 so. So that goes away. So I'm left with 6,400 equals 200 so minus so squared.
No.
Is that true? So we're going to use the quadratic because we have so squared. So to use the quadratic, what does one side have to equal?
0.
So I'm going to have 6,400, depending upon how you want to do this, okay? I'm going to have 6,400 plus so squared minus 200 SO
It's a quadratic formula.
is going to equal 0. All I did was just move the stuff over. Now I can do the quadratic. What's the quadratic? Negative b
Plus or minus squared, b squared minus 4ac.
b squared minus,
Why is it under?
I don't know. He decided.
right? Right? So, if you do all this, how many roots should you get?
Those. Wait, what's
Those. And in this case,
imaginary?
you get 160 and 40. Why does it make sense? If you go through and plug those in, I'm just trying to save some time. If you plug those in, why do you get 2 positive? Why does it make sense that those are 2 roots?
Because there's 2 zeros.
Some's reflected and some's refracted.
There's 2 sets.
What do they add up to?
200.
Oh, they add up to 200. They have to add up to 200. Because of the fact that these 2 dimensions, we said initially that so plus psi had to add up to 200. So as soon as you find one, you know what the other one is. So the beauty of this is that you can set this up where you can have either the so being 160 and the side being 40. Or you can have the side being 160 and the so being the other one. Because there's two possible locations of where you can put the pins. Okay. Whew, that was great.
Hey guys, look at it actually.
Hey,
Is this gonna be on the test bird?
Oh, yeah. Louise,
Hey,
back
we're
shut
gonna
off that camera.
Yeah.
I love it.
I know I said